You ever wonder how Netflix just knows what movie you're going to want to watch next? Or how Spotify builds a playlist that feels like it read your mind? It seems like magic, but it's not. It's a really powerful corner of AI called machine learning. And today, we're going to pull back that curtain.
So that's the million-dollar question, isn't it? We throw that word learn around a lot, but what does it really mean for a machine? Well, it's not about memorizing a bunch of facts. It's about finding patterns so it can make smart guesses about stuff it's never even seen before.
So how in the world do they do it? Well, it turns out that machines pretty much have two main ways of learning. You can think of them as two completely different schools of thought for teaching an artificial brain.
And here they are, supervised and unsupervised learning. Honestly, the simplest way to get it is this. With supervised learning, the machine gets an answer key to study from. But with unsupervised learning, it's kind of thrown into the deep end and has to figure everything out all by itself.
Okay, so let's tackle that first path, supervised learning. This whole world is built on the idea of learning from data that already has the answers included.
The flashcard analogy here is just perfect. Seriously. You show the machine the front of the card, that's the problem. And then you show it the back of the card, that's the solution. You do this over and over, thousands, maybe millions of times, until it starts to see the patterns that connect the questions to the answers.
Now, in this supervised world, you're usually asking the machine to do one of two things. The first is called classification, which is basically just sorting things into groups, like apples and oranges. The second is prediction, which is all about forecasting a specific number, like what's the price of this house going to be.
So classification works like this. You feed the model thousands and thousands of images, and every single one has been carefully labeled by a person. This is an apple, this is a banana, and so on. The model chews on all this data and learns the patterns, the colors, the shapes, the textures. After a whole lot of training, it can look at a totally new picture and say, yep, that's a cherry.
Prediction, on the other hand, is after a number, not a category. So you give the model data on thousands of houses, square footage, number of bedrooms, location, how old it is, and crucially, you also give it what each house actually sold for. The model learns all the complicated relationships between those features to predict the price of a house it's never seen before.
But what happens when you don't have an answer key? Because let's be real, creating all that perfectly labeled data takes a ton of time and money. So what if all you have is a giant, messy pile of unlabeled data? Well, this is where things get really, really interesting.
Welcome to the world of unsupervised learning. Imagine someone just dumped a massive, jumbled box of Lego bricks in front of you. No instructions, no picture on the box, nothing. What would you do? You'd probably start sorting them, right? By color, by shape, by size, just to make sense of the chaos. Well, that is exactly what an unsupervised algorithm does with data. And you can see that process right here. On the left, you've got this raw, unlabeled data. It's just a cloud of dots. But then, look at the right. An algorithm went through that mess and found 3 distinct groups, or clusters. And the amazing part is, nobody told it what to look for. It discovered that hidden structure all on its own.
So why is this so incredibly powerful? Well, online stores use it all the time for customer segmentation. They group shoppers by their buying habits to send them marketing that they'll actually care about. It's also huge for anomaly detection, like when your credit card company flags a weird transaction because it just doesn't fit any of your normal spending patterns.
Okay, so we've seen the two big approaches, but how does a model actually, think? How does it arrive at a decision? Let's take a quick peek under the hood.
This is a decision tree, and it's a classic supervised model. It works by basically playing a game of 20 questions. To figure out a house price, it might first ask, is the house bigger than 2,000 square feet? If the answer is yes, it goes down one branch. If no, it goes down another. And it just keeps asking simple questions like that, narrowing things down until it gets to a final answer. But how does it know which questions to ask? It's actually pretty clever. The whole logic is driven by one single goal. At every single step, the tree asks the question that will split the data into the most distinct, well-organized groups possible. It's always trying to reduce the chaos and create order. This purity meter you see here is a fantastic way to visualize that idea. The goal of every single question is to move the data down the meter, away from that jumbled, impure mess at the top, and toward a pure group at the bottom, where everything belongs to the same category or has a very similar value. Okay, let's zoom back out and put all these pieces together so we can see the whole picture.
This table really sums it all up perfectly. On one side, you've got the decision tree, that's our supervised model, and you use it when you already know the right answers. On the other side, you have k-means clustering. That's the algorithm that found those hidden groups, and it's unsupervised. You use that when you're trying to discover new categories you didn't even know were there.
So really, when you're facing any machine learning problem, the very first and most important question you have to ask is this. Do I have an answer key? Do I have labeled data with known outcomes? Or am I just staring at a messy pile of data hoping to explore the unknown? Your answer to that one question changes everything.
And that leaves us with a really powerful final thought. Especially in that unsupervised world, machines are starting to find connections and structures in data that are just way too complex for our human brains to see on their own. So the big question for the future is, as these tools get even more powerful, what new things are they going to teach us about our own world that we never would have found otherwise?